In section 5 of chapter 5, we're going to deal with the greatest common factor and factoring by grouping. Now, one of the things we've done so far in multiplying is, multiplying monomials, multiplying binomials, multiplying trinomials, but now we're going to reverse it. So if we look at our binomial here, by foiling it, we got to a product that is a trinomial. But we can now factor this through a process we're going to go over to reverse it to its binomial factors. So that's what we're going to do. We're going to start off by looking for the greatest common factor. Now, I think we can jump right into it. There's the rule, but let's take a look at finding the greatest common factor of these individual terms. Well, you do so by factoring each one of these items into their prime factorization. So we take the 20, and it's 2 times 2 times 5. Then we have x to the second, x, and a y. And we do that to each one of these. Now we look at them and say, what is the common factor in each one of them? Well, we see a 5 here. And in regard to the letters, what we see in each one is x to the second. So the greatest common factor of these three numbers is 5 x to the second. And we'll see as we work out an example this process perhaps a little more clearly. So we did example 1 pretty well here. Let's try some other examples. So in looking at A here, we have 8x squared plus 4. And this looks like something we might have done before. So the technique is put a parenthesis here, and we know we're going to have a plus in the middle. Now, of the number, what factor is common to both 8 and 4? And the answer is 4. And then what's left in terms of the number? Well, here there's a 2, and here there's a 1. Now, there is no common letter factor, so this just becomes that. All right, let's do B. 5y minus 2z to the 4th. Now, as we look at that, there are no common factors between a 5 and a 2. And y is only used in one term and z is only, so there are no common factors. But always you can take theoretically a 1 out of anything. And I don't know if that's what they're going to show, but that's what we could do. And let's do this next one here. 6 x squared minus 3x cubed plus 12x to the fourth. So here it looks like there's a common what in each term? Of 3. And we can put our signs in already. And what else is common to each in terms of the letters? Well, can you see we can take an x squared out of each term? So now what's left? Well, 3 times what? 2 goes here. Now there's a 3 goes into 3 once that we're not going to write, but there's an x left over. And here there's a 4x squared. Now keep in mind you can always check these by reversing the process, that is multiplying to get this, and here we factored out the greatest common factor. And in example B, I should also mention there is no common factor of these terms. Again, we said we could always take out a 1, but this is sort of important as well. That is, you can also take out a negative 1 that would reverse the sign. So let's just do that here. 5y minus 2z to the fourth. Now I took out a 1 before, which is not really taking anything out, but if I take out a negative 1, which we need to do sometimes, this will become a negative 5y, and this will become a positive 2z to the fourth. So you could take out a 1, doesn't change anything, you just put this in parentheses. Or if you took out a negative 1, that would reverse the signs. So again, when you distributed, you would get your original expression. In example 3, I've written this here. Now this is not even, this is even. But in this case, as you look at it, you could actually take out a 17. And then you can take x to the third, x to the fourth. So you can take x to the third out of each one, and y to the second out of each one. So in a sense, you've taken everything out of there. So what would be left? Well, you'd have to put a 1 there. And then here it's going to be 2x. Because when you distribute, that is the way to check it. You have to get what you originally started with. If you didn't put a 1 there, you might say, well, I took it out completely. You wouldn't get this when you distributed. So the idea of putting a 1 there is super important. And they're mentioning that there as well. And we'll use the textbook a little bit too. So in this one, as we look at it, we see there is no common number that we can take out. So we look for the x's. X to the third, x to the second, x. So we can take out an x. Then there's a y in each term. We can take out a y. So after we do that, this is what we get. And again, to check it, you would distribute to be sure you get what you did there. Now, they're not, well, they actually are. If you had taken out and you wanted to change the signs inside the parenthesis, if you, instead of taking out a positive 1 here, took out a negative 1, you would put the negative then in front, and it changes all the signs internally. Again, this may be a technique that we're going to use every once in a while, where we want to change the signs. So instead of taking out a positive 1, which we're doing in a sense there, we take out a negative 1 from each term. That changes all the signs. Now as we look at this is one term, and this is one term. Now 2 times something, the 2 and then what's in the parenthesis is a factor. The 3a and what is in the parentheses is a factor. Are factors. And we are then asked, are there common factors in these 2 terms? And you might say, well, yes, what's in the parentheses? Both have this as a common factor. So, can we factor this? And the answer is yes. We take out the common factor, x minus 5, and in a sense we could put this in front. What's left? We have the 2 and we have the plus 3. Now if you remember, we showed when we multiply a binomial and we're not foiling, we could take this, if it were switched around, and multiply it by this, and then this, and multiply it by this. So this is another technique that we'll see here shortly in taking out the greatest common factor. Now, could you have written 2 plus 3a times your common factor, x minus 5? And the answer is yes. You could write it this way too. This and this are equivalent. And in fact, let's just do this one here too. So if we took out the 3, this is our common factor, and the plus 5b from each one, and then it's multiplied by this. So if we were going to use the non-FOIL method, we're saying we'll multiply this by that, and then this by that. And that's what they're showing here. So we can reverse that process as well. Okay, let's look at example 6 now. So here is the common factor. And you might say, if I put a 1 there, makes it a little easier, then this is a common factor. So if I use the same technique, 7x minus 1, and then x squared plus 5y. And again, they have it reversed, which is certainly okay. Again, if you see something like this, just put a 1 there, and then these are common factors. That's going to lead us to objective 3, which is factoring by grouping. Now, in example 7, there are 4 terms, and notice in 3 of them there's a common 2, but that's about it. There's no other common factors of all of them. So how could I possibly factor this? Well, we use this technique of factoring by grouping. And what we do is we look, let's say, at the first 2 terms. Is there a common factor? And you might say, well, there's A. And then I get a B minus 6. Then I look at the next two terms. Is there a common factor? Well, a plus 2. And now I get B minus 6. Taking out a 2 from each of these terms. And now I have common factors. So I can write this A, pick up this A, this 2. And notice if we were asked to multiply these, take A and multiply it by this, take the 2 and multiply it by this, we'd get this. Okay, we have done our first factoring by grouping. In example 8, again, there are 4 terms. Now notice there's a common x in 3, but not the last term. But if we factor by grouping, looking at the first 2, we can take out an x squared. And we get an x plus 5. And in this technique, we're looking, what do we need to do to the last 2 to get an x plus 5? Well, if we take out a 3, we get an x plus 5. And then there are our like terms, or like factors, x squared plus 3, x plus 5. Now notice they're doing it where they put this factor, the common factor, out in front. I sort of like it this way because we said if we're going to multiply this, we take this, multiply it by that, which is what you have here, plus 3, multiply it by that, and then you get this. Now as we do example 9, again 1, 2, 3, 4 terms, and we're going to factor it by grouping. What can I take out of the first 2 terms? Well, I can take out an m squared. And that leaves me with n squared plus 1. Now, you might say, I don't see an n squared plus 1 here, but that's what I want to get here. Now, in order to get these signs, there is a common factor in both of these. What do I need to take out? Because I have to have the signs reversed. And the answer is a negative 2. So we had talked about this earlier. So now we're going to get m squared minus 2, which are these. And we're multiplying these by this common factor, n squared plus 1. Now again, they're writing it in a reverse order, but this one's good, this one's good too. Now as you look at example 10, again we're going to try to factor this by grouping. So in the first 2 terms there is a common x, and I get y plus 2. And if I'm going to get a y plus 2 out of there, what do I have to take out to reverse both signs? And if you said a negative 1, that is correct. So now you get x minus 1, this one, and then your y plus 2. And they're equivalent. Doing this one, you're going to take out a common p and get q plus 3 And then for the last two, you take out a common -1 and get a q plus 3, where you reverse both signs by taking out a -1. So p minus 1, q plus 3. And you did so by factoring by grouping. Now, every once in a while, you might have to switch these around. They may not be originally in the order that you want to do this, and that's okay. You can switch these terms around. That's the commutative property that we spoke of in Chapter 1. All right, we'll go on to do some practice now in our mini lecture.